Welcome, everyone. Let's take a quick journey to see where we're going. We'll start with fractions, which are our first language for describing parts of a whole. From there we move to decimals, another powerful way to express those same parts using place value. Then we explore ratios, which let us compare two quantities directly. When we bring these ideas together, we arrive at the hundredth part, a special benchmark that standardizes all comparisons out of 100. That single idea unlocks the meaning of percentage, a universal scale that makes it easy to compare anything from test scores to discounts. Once we understand the meaning, we'll master conversions, flipping effortlessly between percentages, fractions, decimals, and ratios. Then we'll put percentages to work, finding a percentage of a quantity, expressing one quantity as a percentage of another, and even working backwards to find the whole from a given percentage. Together we'll learn how to increase or decrease quantities by a percentage and the formulas that make it quick, how to solve tricky reverse percentage problems, and how to handle successive changes like a price that goes up then down. We'll tackle word problems, from past percentages in exams to salary restoration puzzles and income comparisons. And you'll see why percentages quietly run everything from calculating a tip at a restaurant to understanding the news. Let's begin. So we just mapped out our whole percentage journey, and now let's start right at the very beginning, with the simplest idea that makes all of it work. Picture it this way. Imagine you've got a big chocolate bar, and you break it into exactly 100 tiny equal pieces. If you take just one of those pieces, that's 1/100th of the bar. In percentage language, we call that 1%, and we write it with the little symbol, 1 followed by a percent sign. On the board you can see it, 1% is exactly the same as the fraction 1/100. That's the core idea. A percentage is just a special way of writing a number as a fraction out of 100. Every time you see that percent sign, your brain should whisper, out of 100. It's like a secret code for fractions, and you already know the key. Now that we know 1% is 1/100th, let's crack open the word itself, percent, because it actually tells us exactly what it means. Follow along while I draw this. The word a percent comes from two parts, per and cent. You might have heard cent before. Think of a century, which is 100 years, or a centipede with 100 legs. Cent just means 100. And a per means for each or out of. So when you stick them together, percent literally means for each 100 or out of 100. So if I say 20%, I'm saying 20 out of every 100. It's a way of comparing things to a nice, round, easy-to-picture number, 100. That's why we use it so much in everyday life. We've just seen that a percent means out of 100, so let's see what that looks like with some real numbers. Let me put this in front of you. Look at the board. We've got three examples, 57%, 25%, and 120%. Now, 57% simply means 57 out of 100. If you had 100 jelly beans, 57 of them would be the ones we're talking about. 25% means 25 out of 100, that's exactly 1/4, right? But here's a cool one, 120%. That's 120 out of 100. You might think, wait, how can you have more than 100 out of 100? And you're right to wonder. It just means you've got more than the whole original amount. Like if you save 120% of your pocket money goal, you didn't just hit your target, you zoomed right past it. Percentages can be bigger than 100, and that's perfectly okay. So 57% is 57 over 100, that's a fraction already, which means we've just done our first conversion without even trying. Now let's get a proper method for turning any percentage into a fraction. Take a look at this picture. The rule is beautifully simple. Since a percent means out of 100, you just write the number as the top part of a fraction and put 100 on the bottom. That's step 1. Step 2 is to simplify the fraction if you can, make it as neat as possible. Let's work through the examples. First, 14%. Write it as 14 over 100. Now, what number divides both 14 and 100 evenly? 2 does. 14 divided by 2 is 7, and 100 divided by 2 is 50. So 14% simplifies to the fraction 7 over 50. Next, a tricky-looking one, 6 2/3%. The mixed number 6 2/3 is the same as the improper fraction 20 over 3. So we put that over 100, 20 over 3, all over 100. That's the same as 20 over 300. Simplify by dividing top and bottom by 20, and you get 1 over 15. For 224%, it's 224 over 100. Divide both by 4 to get 56 over 25, which is an improper fraction. As a mixed number, that's 2 and 6 over 25. And 175% is 175 over 100, which simplifies to 7 over 4, or 1 and 3 over 4. And here's why that works. Percent literally means out of 100, so writing it as a fraction over 100 is just translating the word directly into math symbols. No magic, just meaning. We just turn percentages into fractions by putting them over 100. Now, what if we want to go the other way, take a fraction and turn it into a percentage? Here, look at the board for a moment. The rule flips. To change a fraction to a percentage, you multiply the fraction by 100. Let's try it. Take 11 over 16. We do 11 divided by 16, then multiply by 100. 11 divided by 16 is 0.6875, times 100 gives us 68.75%. Next, 3 2/3. Change that mixed number to an improper fraction first, that's 11 over 3. Now multiply by 100, 11 over 3 times 100 is 1100 over 3, which is 366.67% when you work it out. And 7 over 4? Multiply by 100, 7 over 4 times 100 is 700 over 4, which is 175%. Quick heads up, don't confuse this with changing a percentage to a fraction. Here you multiply by 100 to go the other way, whereas converting a percentage to a fraction involves dividing by 100. They're opposite moves, like forward and reverse. We've mastered fractions and percentages going both ways. Now, a ratio is just another way of comparing two quantities, and you can write a percentage as a ratio too. Stay with me on this one. The steps are up on the board. Step 1. Write the percentage as a ratio with 100. So 32% becomes 32 to 100. Step 2. Simplify that ratio just like you would a fraction. 32 and 100 can both be divided by 4. 32 divided by 4 is 8, 100 divided by 4 is 25. So 32% is the ratio 8 to 25. Let's do 27.5%. Write it as 27.5 to 100. To get rid of the decimal, multiply both sides by 10 to get 275 to 1000. Now simplify, divide both by 25, and you get 11 to 40. And 175%? That's 175 to 100, which simplifies by dividing both by 25 to 7 to 4. Just like fractions, we're always looking to make the numbers as small and friendly as possible. We just turn percentages into ratios, so naturally, we need to be able to go back the other way, from a ratio to a percentage. Let me sketch this out for you. The process has 2 steps. First, write the ratio as a fraction. A ratio of 23 to 40 becomes the fraction 23 over 40. Second, multiply that fraction by 100, exactly like our fraction to percentage rule. So 23 over 40 times 100. 23 divided by 40 is 0.575, times 100 gives 57.5%. Let's try another, 143 to 125. That's the fraction 143 over 125. Multiply by 100, 143 divided by 125 is 1.144, times 100 is 114.4%. Notice that's over 100%, which makes sense because the top number of our ratio was bigger than the bottom number. You're just using the same fraction to percentage skill, but starting from a ratio format. We've connected percentages to fractions and ratios. Now let's link them to decimals, which you see everywhere, on price tags, in sports stats, on your phone battery. Watch as I put this up on the board. To change a percentage into a decimal, you do two things. First, remove the percent sign, just take it away. Second, divide the number by 100. Remember, percent means out of 100, so dividing by 100 is how we undo that. For 73%, we take 73 and divide by 100, which gives us 0.73. The decimal point moves 2 places to the left. For 32.5%, we divide 32.5 by 100 to get 0.325. That's it, drop the sign, divide by 100, and you've got a decimal. It's like translating between two languages that say the exact same thing. Now that we can turn a percentage into a decimal by dividing by 100, going the other way is just the opposite move. I'll show you what I mean. Picture this. To change a decimal into a percentage, step 1, multiply the decimal by 100. Step 2, stick the percent sign on the end. So for 0.37, we multiply by 100 to get 37, then add the percent sign, 37%. For 1.23, multiply by 100 to get 123, add the sign, 123%. Again, over 100%, which is totally fine. It's the reverse of what we just did. Instead of dividing by 100 and dropping the sign, you multiply by 100 and put the sign back. Think of it as a dance, 2 steps left, 2 steps right. We've just practiced converting in both directions, so let's cement that by looking at a few more examples side by side. Let me put this in front of you. On the board, you can see pairs that mean exactly the same thing. 73% is the same as the decimal 0.73. 32.5% is the same as 0.325. On the flip side, the decimal 0.37 becomes 37%, and 1.23 becomes 123%. The big takeaway here is that percentages and decimals are completely interchangeable, they're just two different outfits for the same number. Whether you see 0.37 on a calculator or 37% on a test score, you're looking at the same amount. Getting comfortable switching between them is like being bilingual in math. Alright, we know what percentages are and how to switch between forms. Now the really useful part, finding a percentage of an actual amount, like a discount at a shop or a tip at a restaurant. Follow along while I draw this. The formula is right here. You take the percentage, divide it by 100, and then multiply by the quantity. Let's use it. 33% of 50. We write 33 over 100 and multiply by 50. 33 divided by 100 is 0.33, times 50 gives 16.5. Next, 6 2/3% of 3 meters. Change the mixed number to 20 over 3, put it over 100, and multiply by 3. That's 20 over 300 times 3, which is 60 over 300, or 0.2 meters. And 0.6% of 35 kilograms, 0.6 over 100 times 35. 0.6 divided by 100 is 0.006, times 35 is 0.21 kilograms. Here's one for you. What is 20% of 80? Pause the video and work it out. Ready? It's 16. 20 over 100 times 80, 0.2 times 80 equals 16. We found the part when we know the percentage. But what if you know the part and the whole, and you need to figure out the percentage itself, like your score on a test? Take a look at this picture. The formula is on the board. Percentage equals the part divided by the whole, then multiplied by 100. You're basically asking, what fraction of the whole is my part, and how do I say that out of 100? Let's try one together. If a student scores 18 marks out of a possible 25, what's their percentage? The part is 18, the whole is 25. So we do 18 divided by 25, which is 0.72. Multiply by 100, and we get 72%. That's a solid score. Here's one for you. Pause the video and try it. If a student scores 18 marks out of 25, what is their percentage score? Work it out. Got it? It's 72%. 18 over 25 is 0.72, times 100 makes 72%. So we just learned how to find what percentage one number is of another. Now let's flip that idea around. If you already know the percentage and the part, can you find the original whole? That's exactly what we're doing here. Let me put this up on the board. Imagine a mystery number, and we're told that 8.5% of it equals 68. You can think of it like finding a hidden total from a tip. If you know the tip amount and the tip percentage, you can figure out the original bill. We start by writing it as an equation, 8.5 over 100 times that mystery number, let's call it x, equals 68. To get x alone, we flip the fraction, multiply 68 by 100 over 8.5. That gives us 68 times about 11.76 for 7, and when you work that out, x turns out to be exactly 800. So 8.5% of 800 is 68. This is what happens when you see a sale sign saying 40% off, you saved $20 and you want to know the original price. Now that we can find the whole from a percentage, what if we want to make a number bigger by a certain percentage? That's our next step, increasing a quantity. Follow along while I draw this. Say you've got 200, and you want to boost it by 15%. You're not just adding 15, you're adding 15% of the 200 itself. So first find 15% of 200, which is 0.15 times 200, giving 30. Then add that to the original, 200 plus 30 equals 230. You can see on the board how the arrow moves from 200 up to 230. This is like getting a 15% raise on your allowance. Your new amount is your original plus that extra chunk. That step-by-step adding works, but there's a faster shortcut, a formula that does it in one shot. Here, look at the board for a moment. To increase any number by a percentage, you multiply the original by 1 plus the percentage as a decimal. Let's try it with 360 increased by 15%. The 1 represents the original 100% of the number, you're keeping all of it, and the 0.15 is the extra 15% you're piling on top. So it's 360 times 1.15. Do the multiplication, 360 times 1.15 gives 414. Same answer, way fewer steps. Quick heads up, don't confuse this with the decrease formula. Here you use 1 plus the decimal, whereas for a decrease you'll use 1 minus. We'll see that next. We just used 1 plus to increase, now let's do the opposite. When you want to shrink a number by a percentage, the formula flips to the 1 minus. Watch as I put this up on the board. Take 240 and decrease it by 10%. That one still stands for the original 100%, but now we subtract the 10% as a decimal, 0.10, leaving us with 0.90. So we multiply 240 by 0.90. And 240 times 0.90 is 216. Notice the pattern: increase uses plus, decrease uses minus. This is exactly what happens when a store takes 10% off a $240 item. You pay $216. Alright, we've increased and decreased, but what if we only know the final price after the change, and we need to rewind back to the original? That's a reverse percentage problem. Let me sketch this out for you. Imagine a price went up by 20% and became $240, but the original sticker is a mystery. Since the final $240 is 120% of the original, that's the 100% original plus the 20% increase, we can write it as original times 1.20 equals 240. To undo that multiplication, we divide. 240 divided by 1.20 gives us 200. And here's why that works: dividing by the increase factor reverses the multiplication, taking you straight back to the original amount. This is super handy when you see a price after tax and want to know the pre-tax amount. We've got the formulas down, now let's see how they show up in everyday stories. Percentage word problems are everywhere. Take a look at this picture. You might read about apples where 25% of 200 are red, that's 50 apples. Or a salary problem: the 10% raise on a $3,000 monthly salary means an extra $300. Or a sale: 20% off an $80 jacket drops the price to $64. Here's how you crack these every time: read the problem carefully, spot the original amount and the percentage, decide if it's going up or down, then pick your formula, increase or decrease, and plug it in. The math is the same, the story just dresses it up differently. Now that we can handle single-item percentage problems, let's look at mixtures, where percentages describe what something is made of. Stay with me on this one. Picture an alloy, which is just a metal mixed from others. This one is 60% copper and 40% zinc. That means if you had 100 grams of the alloy, 60 grams would be pure copper and 40 grams would be zinc. The percentages tell you the recipe, they always add up to 100% because together they make the whole thing. You see this in election results too, where candidates' vote shares add to 100%, or in nutrition labels where fats, carbs, and proteins make up the total calories. Mixtures showed us how parts add to a whole, but what happens when a single number gets changed by a percentage, then changed again? That's successive percentage changes. I'll show you what I mean. Picture this. Start with 100. Increase it by 10% and you get 110. Now take that new number, 110, and increase it by 20%. 20% of 110 is 22, so 110 plus 22 lands you at 132. Notice the second bump applies to the already bigger 110, not the original 100. That's the key insight: you can't just add 10% and 20% and call it 30%. The second change works on a new base, which is why the final result is different from what you might guess. Building on that idea of successive changes, here's a classic trap: increasing then decreasing by the same percentage. Let me put this in front of you. Start again at 100. Go up 10% to 110. Now drop that 110 by 10%. 10% of 110 is 11, so 110 minus 11 gives you 99. Not 100. The decrease took away a bigger chunk because the base was larger. Here's one for you, or a price is increased by 10% and then decreased by 10%. Is the final price the same as the original? Pause the video and work it out. Ready? No, it's 1% less than the original. The numbers don't cancel out because the second percentage bites into a bigger amount. So an increase followed by a decrease doesn't get you back to square one, but what percentage would restore the original? That's a salary restoration problem. Picture it this way. Imagine your salary drops by 20% from 100 to 80. Now your boss feels bad and wants to put it back to 100. What percentage increase on the new, lower salary of 80 gets you there? You need to add 20, and 20 as a fraction of 80 is 1/4, or 25%. So it takes a 25% raise to undo a 20% cut. The percentage back is always larger than the percentage cut because you're working from a smaller base. That restoration idea hinged on which number we used as the base, and that same careful choice of base matters when we compare two people's incomes. Let me sketch this out. Say A earns 100 and B earns 80. If someone says A earns 25% more than B, they're using B's income of 80 as the base. The difference is 20, and 20 over 80 is 25%. But if you flip it and say B earns 20% less than A, now the base is A's 100, and 20 over 100 is 20%. Same difference, different base, different percentage. Always check whose number is the whole in the comparison, it changes the percentage completely. We've compared incomes, now let's wrap up with a situation every student faces, figuring out the passing marks on an exam. Here, look at the board for a moment. The total marks are 200, and the pass percentage is 40%. To find the minimum marks you need, it's just a percentage of a quantity from earlier, 40% of 200. 40% as a decimal is 0.40 times 200, gives 80 marks. So you need at least 80 to pass. On the board you can see the line 80 and above is safe, below is fail. This is the same math as finding a tip or a discount, the context just changes. So we just figured out how to calculate pass percentages and marks. Now let's see what happens when a student takes more than one subject. Picture this on the board. Imagine your class just got results for math and English. Some kids passed math, some passed English, and a few lucky ones passed both. We can use two overlapping circles to sort this out, one circle for math, one for English. The overlap in the middle? That's the group who passed both subjects. Now, here's the trick, if you just add the math passes and the English passes, you've counted the both kids twice. So to find the total number of students who passed at least one subject, you take math plus English, then subtract that overlap. It's like when you're counting your candy, if you and your friend both have some of the same kind, you don't count them twice when you pull it all together. This keeps your total clean and accurate. Now that we can handle overlapping sets of students, let's arm you with some instant memory tools, common percentage fraction pairs. Let me put these right in front of you. Knowing these by heart is like having a secret decoder ring. You can switch between percentages and fractions in a snap without doing any math. Look at the board, 50% is exactly half, so it's 1 over 2. 25% is a quarter, 1 over 4. 10% is 1/10, 1 over 10. A tricky but super useful one, 33.33% is 1/3. 20% is 1/5 and 12.5% is 1/8. Why does this matter? Say you're splitting a pizza with 3 friends and you each get 33.33% of it, that's just 1/3 of the pizza. These pairs make mental math lightning fast. Here's one for you, what's the fraction equivalent of 25%? Pause the video and work it out. Ready? It's 1 over 4. You've got those key fraction pairs locked in, and now let's use them as a launchpad for some seriously fast mental shortcuts. Follow along while I draw this. The secret to quick percentage calculations is breaking a number down using 10%, 5%, and 1% like building blocks. Check out the board. To find 10% of any number, you just move the decimal one place to the left, so 10% of 80 is simply 8. 5% is easy too, it's just half of whatever 10% was, so half of 8 is 4. Now you can build anything. Want 15% of 80? That's just 10% plus 5%, which is 8 plus 4, giving you 12. And 1% is just moving the decimal 2 places. 1% of 80 is 0.8. This is what you're doing when you're at a store and a 15% discount sign pops up. You can figure out the savings in your head before you even reach the register. It's like having a calculator built right into your brain.